I guess we're live. Let's check it out on the page. Yeah, well, that works. All right. Welcome again. Oh, there we, there we go. We have a delay in the stream there. All right. I can close off this. All right. So welcome again. Martin seems to be. He sent me an email saying that he's on mobile mobile Wi-Fi at the moment. So it looks like he will not be able to join. We're continuing our series on our quantum Tic Tac Toe game. Last week we spent quite some time on trying to figure out how to make the links between all the cells. And to actually find the path between all the subcells when you create an entanglement. I guess we found out that our data structure that we have is not very efficient for the thing that we want to do. After the live show last time, I went in and tried to figure out the entire... Hey, Martin is here. Let's call him. I tried to figure out the entire. There we go. Let's see what happens. So I tried to figure out the entire recursive path finding thing. And I kind of got it to work. Let's see, this Google Hangouts thing is not working. Let's Martin, the Hangouts is not connecting. So in the end, I found a solution that, given a test case, it will render us a path, and it will do it in quite a consistent and usable manner, but the way of getting there is actually quite it entails a lot of steps. So let's take a look at what it actually means. I did a depth first search, and basically, yeah, so we grab the cell, we grab all the other cells, we remove the cell that we already visited, and then we go in. And as you notice, there's a lot of extra calls to get the data about the path. So Martin dropped me an email and said, well, I don't think that the structures are okay. And if we look at what we want to achieve, I think he has a very valid point. Currently we have I put it in a Word document. We have this structure here. Let's zoom in a little bit, because I know the resolution is a little bit high, so the text will be small on the screen. So we have this we have a board which has indexed cells, so 0, 1, 2, etc. And each cell has a cell structure. And currently our cell structure is that we directly indicate the subcell and then give it the metadata. So the board here translates to a subcell of 2 and with the metadata that it is toggled, that it has on which turn it happened, which player, and to what other cell it is entangled. And what we need to do is also later on, if we do a more visual inspection of the board. Yeah, I don't know if it happens. Yeah, I think Martin is his connection is quite dodgy at the moment, I think. So what we want to have happen on the board as well is currently we have this setup right here, and what we want to have happen is that, let's see what it's the brush. we want to go from a cell that has 9 subcells to a, can I not draw? I want to draw. Yeah, there we go. So excuse my drawing skills. Like my 5-year-old is better at drawing than I am, right? So we want to go and have these cells marked as classical and use that from that point on. So we have 2 states of a cell. So either it is in a position where it can be entangled, so every subcell can be entangled, or it has a classical state. So what we want to achieve is that for this cell we can have some form of metadata that either says, well, it is in this entanglement state, or it is in this classical state. So currently we do not have a way to do this, so we actually made a problem here for ourselves. And I think we need to redefine I don't know if you hear that, but the dog, the puppy, he hears me talk on the show, and then he goes, oh, I want to be on the show as well. So he's waking up now. That's he used to do it after about an hour, but now he knows when I'm talking upstairs, so he will try and get upstairs. So let's see if he continues to bark, and if he does, then I will grab him. So I think we want to move the metadata of the entanglements basically into a separate structure, and that way we can basically say either this cell has entanglements or it is a classical mark, and then when it moves into a classical mark we can actually disassociate the entanglements and get rid of it. And that seems to clean up the entire thought process about the board. There's also another case that we need to take a look at, and that is if we have an entanglement, so from here to there, from here to there, and then from there, from here to there, and from there to here. That means that when this board collapses, this little piece also collapses. So, all right, so the puppy is barking. I will grab him, and then he can join us on this show, and we will get started on fixing our data structure. So 1 second, I'll be right back. So there we go. Puppy in the house. All right. So the moving the entanglements. One thing that I would also like to see happen is that we can regenerate a board from a state, right? We need that later on. Currently we just generate a board given a empty state, and then we have all the modifications. So yeah, so we should get started on that. It seems like not a big change to move the metadata into a sub state. It leaves room for the entanglements as well, for the movement to the classical state, and then based on the state of a cell, either it has an entanglement or entanglements really, or it is classical, we can render the cell. So that should be a good move as well. Yeah, and the path recursion, then it would only need to return the cells, because that's where we had a struggle last time, is that if we take this board, for instance, let's move that down a little bit. If we take this board, can we make it a little bit bigger, right? So if we take this board and we take my awesome drawing skills, there's this link right here, and then this one moves right here, and then this one moves right here. We have this really cool smiley face, and that creates a entanglement that needs to be observed. So this one will be 0, 2. Right, I cannot draw like that. Let's forget about that. So let's say that. Serious. All right, my battery just died. You believe that? I should heed the warnings of a thing. So let's do the trackpad. So if we choose this cell for the collapsing, that does not work. Hey, that does not work. Rustig. Yeah. Come on. Yeah, the puppy is a little bit anxious because it's actually nap time, man. It's nap time. No. You want to chew. It's becoming so big. So, oh, that's horrible. So we need to collapse it, and then we can get rid of this cell, which means that the only other cell in the path that is part of that top level cell is the X. So that will actually remove this cell, and thus we continue marking the cells that are not part of the path anymore, and that should leave us with a collapsed board, right? So given the path, we know cell 1, 0, 1, 2 are connected, and we know we can say, well, choose to observe cell 0 by turn 0 in this case. That means that the O is the active player. That means that we can remove the pair of the entanglement from the board. That results in cell 1 only having one occupant, and that means that we can remove that pair from the board as well, and then we would continue in a cycle like that until every cell only has one occupant, and that should actually work quite nicely. So let's see, and let's remove the entire mouse using area of the board. So should work now. All right, let's give it another try. Hey, Martin, last try for Martin to join. Hello, Martin? Are you still there?
Can we make this work, do you think?
Well, I don't know. Do you hear me fine now?
I do.
I do. I hear you as well. So it seems to be working on your mobile phone.
Let's give it a stab, and if it stops working, we'll just drop it. But
Yeah.
Let's see how it works for now.
Oh, beautiful. All right. Yeah. So I just had a monologue on the game
Yeah,
stuff.
I did track most of it, so no problem. I think we can pick up where you're at.
Yeah. So what do you think about moving the entanglements and classical state into its own sub-cell type thing?
I think it makes sense. The only thing that I'm sort of trying to figure out if it will work well is this calculating the consequences of an observation. I mean, the other, besides the immediate collapse that you see when you choose to observe one cell, I can't really figure out if we are making life harder for ourselves in calculating the other collapses. But I'm not sure.
I don't know either. The one thing that we realized last time was that the entanglements and the board structure needs to change a little bit in order to
For sure.
have the classical marks.
Yes.
So yeah, so let's get to that. Yeah, doggy. Yeah, rustig. You want to say hi? Hello. He becomes more and more active every day, right?
Yeah.
Okay. So, Boon, grab your bone. Grab your bone. Nee, niet mijn hand. Nee, nee. Alright, dog wrangling 101. Alright. And the mouse stopped working, which is fine, because we don't need a mouse, really. So, alright. You're making this very hard, doggy. Alright.
Quantum stuff is hard enough as in the first place, I think.
Yeah, indeed. Alright. So the other thing that I want to achieve is that we can redraw a board from a state, right? Because that would help a lot, also in test cases and stuff like that. So let's start it with that. No. If he's not going to stop, I'm going to grab your basket and put you right down, right? Alright. Let's see, where's the board? Yeah. So we have the events and we have the fuse, right? Hey, alright. So the fuse in himself. Did you, by the way, see the article on getting the Reframe subscriptions to be a better version of itself?
Yes,
yeah.
I did.
Yeah, this is quite nice. So I copied over the sub and the event dispatch thing. So it seems like a good improvement on the entire system. Let's see. That should stop working. Alright. Dit gaat zo niet werken, vriend. I'm going to grab a very nice snack for him because he's going a little bit insane, and that's driving me insane because I cannot do nothing, man. So, alright, Martin, I will be right back, and then we should... Alright. So I basically gave him the equivalent of a Scooby snack, I guess. So he should be calm for a little while. Alright, so let's get started. So we have the database structure, we have a board, and so basically we're saying that a index of 0 will have a cell, and that would of course be a comment, right? And a cell will be
the image window into the Hangout.
Oh yeah, sure. Let's see. I don't have a mouse, right? Share the screen. Yeah, sure. All right,
Excellent.
there you should have it.
Yeah.
All right, and a cell would have an entanglements, right? And that would be the subcells with their metadata. And the other state it can be is the classical mark. So if we, and that should have a metadata. Hey, there's Soding. So, all right. So let's first focus on just grabbing, redrawing a board based on the state, and then that way we can use the state to actually work out the rest of the logic from there again. It's kind of like starting at the beginning again, I guess. All right, so let's see. We have all this generate cells, and generate cells, create cell, which is open. Let's see. So that might not be the most. It was very nice what we did, but probably would not be the most useful thing that we did. I guess what we need to do is to say create a range of 0 through 8, right? And then from that range grab index from board, and if it has entanglements, draw a subboard type thing, and then if classical add classical mark. So that would render a what did we call it? Superposition board, right? Yeah, superposition board, and this would be a classical. Yeah, so we can render the classical board, and this would be a render superposition, and a superposition would do the same thing, the range, and then take that from the subboard, right? Started one. Yeah, and then we can grab, yeah, take the range 0 through 8, and that would grab a subcell from board cell, board, right, and then render cell. Right. Either it is nil and there's nothing, or there is an occupant basically. Let's see, so the generate superpositions, generate cells open, and we had this range, right? What did we do? We had to create cell, which is classical superposition, generate cells open. Yeah, the partition tree, tree range 9, right? So that gives us the blocks of the sets of trees. So that should give us like 0, 1, 2, 3, 4, 5, 6, 7, 8. And that generates the rows. So that's fine. That's fine. That creates cells. I guess what we need to do here to create cells, we only need to say the type would be part based on the. We can enhance this, right? We based on the current definition of the board. We can grab the type from the board itself. Either it is nil and then it would be the or superposition, I guess. Yes. And then we have to create cells, generate cells open, and that creates cells open. Did we put ourselves in a position where we cannot reuse it? All right, let's put the board in a state. So let's for now assume that we have this cell and it has entanglements. What would be subcell? Yes, it is. So it is on GitLab. Let me grab the URL. We do everything with the keyboard today. Sign in, that should be build fun things. There we go. So there we go. Yeah. All right. So an entanglement, it has a subcell index, and then basically we can say turn 0, right? And we'll have a connecting point on the other side, so that would be a pair, I guess. Yeah, pair is a good name, right? And then we can say a 1, 0, and that means that we can say the fourth, right? And cell 1 will have entanglements 0. Also on turn 1, turn 0, right? Pair 0, 1, 0, 0, right? All right, so that should render a board where cell 0, subcell 0, and cell 1, subcell 1 will have their own marks. And then for argument's sake, let's say that we have the classical marks already for cell 2 and 3. So this should render the first two cells being probably the O's, and then cell 2 and 3, so top right and the first one of the middle row being the classical mark, so having a complete board already. So the classical Tic Tac Toe look and feel, which we have not implemented yet, so that will be also very nice to see. So let's give that. Now let's see. Oh, okay, that works. Alright, you sometimes forget how to do stuff with your keyboard if your mouse is not working right. Let's see. Are you still there, Martin? By the way, you're very quiet.
I am.
Ah, there we go. All right. All right. So let's, for argument's sake, say that we have this generate cells right here. Cells, and if I remember right, create cells, and this actually renders the single cell. So if we do the prn cell of parent, this should render parent and cell. So this should render, oh, sorry, I did that. Yeah, Yeah. Oh, that's interesting. 5, 6, 7, 8. Yeah, so this renders the entire board, right? As we expect, and so we can all the and that creates the cell of the superposition and open, I guess, and classical, right? So if we then grab the
where do those nils come from?
yeah, I was wondering that as well.
That's weird. More there.
Yeah.
What's so special about? Yeah, you don't even know which one it's trying to find this a top level cell that doesn't exist.
Yeah. A parent that does not exist, and it is 0, 1, 2, 3, 4, 5, 6, 7, 8. So it looks like it is doing something at the end of a list, probably.
Yeah.
So that would be at the range right here, right? So this does not. So would it be the for loop itself that has a nil position as well? The PRN cells. It's only the parents. Now let's see what it does. Then we can remove this PRN because else we will have madness. Right, and now we 0, 1, 2, 3, 4, 5, 6. There's no nil reference here, so that's interesting. Huh. All right. Well, that's something. Let's see if it magically goes away when we fix this stuff, right? Right. So what we said was, if we have this for loop. God. Now I did bad things, I think, right? Move this one out. We can introduce a let for this. So we want to actually have the metadata of the cell, and that means that we would do get in, and we need the board for this, right? Yes, we need the board. So when we create the cells, we should actually pass along the board that we are trying to create. But it's actually part of the DB. But the DB itself is right here. So we need to create a subscription for the board. Yeah, that works. Reframe subs. And I just said I would try to use the suggested new thing, and it did not. Subs. We need the subs. Not that one. Subs. Right. Apparently this structure is also in the new reframe. It is up for a great simplification, right? Yeah.
Yeah. You wanna stick to the old way of doing things?
Well, I don't know the new way yet. So either you teach me now, or have you? I'm thinking you have a lot of experience with new structure already, or not?
A bit, but let's just stick to this for consistency,
Yeah.
and we can. I think we can switch it over next time or something
Yeah.
and make that a specific activity.
Yeah, you want to plug your talk at Closure Days still? I was very excited to see that it was accepted.
No, I think it's gonna be fun. I don't know what I did to deserve it, but I got the absolute last slot of the day
Yes.
where people are asleep and or drunk.
Yes. Well, let's hope for
So,
the last one.
so I think I have to do something to grab people's attention, but I know it's yeah. As I've built this prototype for a product using Reframe and also a couple of cool technologies that I think would be interesting to people for people to hear about. That also sort of gives you a very one thing I like about Reframe is that even though you're prototyping and maybe you're doing some shortcuts, it gives you a fundamentally sort of same way of organizing things, right?
Yeah, true.
And that's part of the theme of the talk because I'm also using CouchDB and PouchDB, which is an in-browser database basically that has this amazing capability that it can sync seamlessly with a CouchDB backend.
Okay, that's quite amazing.
So that's those superpowers that you get from that is going to be one of the things that I'm going to be talking about.
Nice. And I also read that you used to be a lawyer.
Yes.
Yes.
That's true.
You
For 3 years, I was started out as an IT lawyer, and then I managed legal departments for quite a few years.
Nice.
In some big companies. But 1st of January 2016, I resigned from my job at that point in time and started my own company.
All right.
Yeah.
Huh. Nice.
So Closure used to just be a hobby. And I think, the reason I picked it up in the first place was that I didn't have an employer, telling me what to choose and what to choose. So I was sort of free to pick anything that I thought made sense. And
yeah.
Turns out that it did make sense, and people are actually now doing. A lot of people are doing commercial work using Closure.
Yeah. It is becoming quite the hip thing to do, right?
Yeah.
And for good reason as well, right? Because it allows you to do so many useful things really rapidly.
Yeah.
I remember back in the day when we built the eBuddy front ends. It used to be a messaging company. It still is a messaging company. It's not no longer doing the MSN, Yahoo type messaging, but more on the WhatsApp type messaging. But when that was back in 2006, damn, it's already 11 years ago, and we created a JavaScript front end for our application. It need to be like an actual chat client and type things. So the front end guys, I wrote the back end, but the front end guys, they had to create their own JavaScript event handling and observables and all those type of things, and it was a mess, right? It was a mess.
It's so hard to get right in the sense that it's also robust.
Yeah.
One thing is writing it for yourself and you can make it work, but writing something for a team that is sane enough that that people do not trip themselves up all the time is just immensely hard, right?
Yeah, indeed. Very true. Very true indeed. Well, you see that entire reframe structure and makes it very easy to make these type of things, right?
Yeah, I think this idea that it's keeping you fundamentally sane, even though you're moving fast, and you might be writing some dirty handlers, right, that are not as they should be, but it's pretty safe because you still know where they are. You can go back and refactor them and make them pure and whatnot, and it's not as if all kinds of the shortcuts and the weak points are very easy to find, and the overall structure is fundamentally sound. And
yes,
that makes a huge difference, right?
Indeed. the
You
things
can
that
actually take something on a prototype level and start
yeah,
moving it to production, which is what always happens, right? You're always told you need to scrap your prototype,
yeah.
and I mean that doesn't happen very often. What happens is people try to evolve the prototype into a production, and
True.
that always happens. And it's and if you're doing that based on a foundation of mod, then that's really dangerous. But something like Reframe and the agent for that matter too gives you a much more stable foundation.
Indeed. The nice thing I like about it is that it allows you to actually um, take the things that are production worthy, and as they are pure functions, you can move them around uh, from your prototype to your production code, and you don't have to worry about it too much. If you used to do
Yeah.
that within a big Java code base, for instance, you have to refactor all your code, and it ends up being a pile of mess.
Indeed.
So, all right.
Oh well, let's get back to you're typing away and
Yeah, I'm listening to your wisdom. Um, I was adding the board to the yeah, right. So I was adding the board to the what was I doing? All right, I'm doing multiple things at once. I'm adding the board to the cycle of creating the cells.
yeah.
And what I did was to um, uh, I'm trying to find the metadata of the cell itself, uh, to work on it. Because I added, yeah, there we go. Let me finish this real quick. When not nil meta, let's print it because else we get all the nils. All right. So what I did is I added the board to all the calls. And basically, when we are now calling the create cell, which actually calls the def method of the cell specifier, basically, I'm passing along the metadata. So now we know which turn it was and what connecting cell. And what I see now already, let's see this, right? It should reload, and yeah, so now we have either an entanglements or a classical cell. So based on that, we can move the board to either the class that was passed along to it or to the specific uh, already defined class, I guess. I'm wondering about the top level cell at the moment, but yeah, I think it will be fine. So let's see what the dog is doing. I guess he went through his Scooby snack. You did that quite well, quite fast, man. All right. So yeah, so we get the metadata. We know that the cell has either entanglements or it has a classical state, right? Um, so for well, it actually has three states, right? If there's nothing, it will be nil. So we can have a condition seeing nil. For the meta, then we can actually do what we've been doing at the moment, right? So that should render us something very similar to what we have now, with exception of a few cells, right? All right, so now we know that um, um, cells 4, 5, 6, 7, 8, they have nothing, so they are rendered based on the basic state of the game. which is the thing that we've been doing all along. And now we can say, based on the data in the cell, or the metadata, I guess the metadata is the wrong name, but we can start rendering either a classical cell or a cell with entanglements. I am wondering, however, because we reuse the same logic for either the top level cell or the sub cell, it will also be called for the top, the sub cell, right? That is this area here. So this will actually create the subcells, right? I guess. Either it's that or that, and then we'll go back into. So if we do not render a superposition, if we do not render this one, then it should be. So if we just say, if nil and else, let's give it a try. Let's render this as a classical. Let's see what happens. Else, is it else? Else, right? Nice. Let's see what we did. What did we do for the this one? Let's render an X. It's now right. So it is actually going in and rendering every subcell. Yes. So this is not working as intended. Because we're reusing the same logic. Our very beautiful board generation thing is falling apart already.
I'm just wondering if
oh, I see. I think.
So, it did work. What have we, just moving back, what have we fundamentally changed here? You're passing in the.
Well, no.
Go ahead.
The dog is also having an opinion. Now, what we did here is. What is it? Kom maar. Tyler, kom eens hier. You want to be part of the conversation, don't you? Yeah. We actually told it to render a superposition board. And the cell for superposition always generates the random, the open board. So that's why it is iterating into the subcells. So we need to change that. I need to find a good way to deal with the dog during these sessions. It is very interesting.
The protocol for create cell, that used to work.
Yeah, maybe there's something else going on, right?
So what you have to do is that you're passing a cell that's marked as classical. It should dispatch to the method you have just above. Right?
Yeah. Well, it does. It does that for the subcells, right? But it should go for a top level cell. Create cells. Yeah. The.
Yeah. Okay. Now it's okay.
You see it? It's.
Maybe that was too clever.
We were too clever for our own good. But I guess the thing is that to generate cells, the one here, it already goes over the top level board, so we need to make the distinction there, right? Either it
Yeah.
has a cell with entanglements or it is a cell with a classical mark. So currently I added the distinction I added on the creation of the cell itself, which is not the right one. Hey, doe eens even kalm, man. Let's see. Gaan we lekker liggen. So, let's see. Give the dog his chew toy. Go and lie down. No, he's too active. Alright, so when we actually do the generation of the cells, we need to actually grab some of this already. Alright, and then we remove this one, right? If it is nil, then just do the thing that you already did. Let's see, then it should no longer render the first 4 top level cells. Alright, and then if it has entanglements, let's see, so we have the entanglements. If it's nil, if it's not, then it, in that case, you need to sleep, man. There you go. Alright, let's see if it has what we do if it has entanglements, render subcells. If it has classical, render classical, right? So let's say, I wonder if this works, right? Not nil. No. Not. Not nil. Classical. Let's just give that a try. Right, then that should render a cell of type classical. Good, getting there. So yeah, those cells are as classical, but I would expect it to stop there. Generate cells. So why is it still rendering the subcells? We call generate cells, right? Which is somewhere around here, right? So we generate cells with superposition as type. That gives us the tree list of the board, and then for each cell in that we move along. We grab the index, and we grab the index, and that should result in just a single line entanglement. So what does this do? Cells? Oh, cells. Yeah, so that just gives us each row, right? Yeah, it gives us each row, and so basically these cells iterate over the row, and then we call create cells. I would have expected that this one, or is meta is not nil, right? Paren meta is not nil for those ones, so that should into classical. Classical should render into paren, so it is not going into the create cells. No, it should call a create cell, right? Right. So that in this case we need to run. Yeah. Get a puppy, I say. It will be relaxing, right? Will actually be something like this. Do we have enough information on that? The class will actually be classical already. That should render it back a bit. An X? No. Use Tago. And it will be. Oop.
That was unexpected.
8. Okay.
So
Oh. Yes. Okay. We generate the cells for a parent, so 0, 1, 2, and 3. And then we say, give me every row in there, and let's render the rows. So actually, this condition needs to move up.
Yes, you need to move it outside the loop.
Indeed, and if it is, if I don't want the comments, right? Do you need to go for a walk? No. Oh. All right. I guess there's nature calling for the doggy. Let's see.
Yeah, well, you don't want to mess with that.
No, because it will get very messy. So if it is nil, then we do right.
Yeah, and otherwise we just do a regular cell.
Where did it go? Undo. Cells. Well, cells is undeclared at this moment. Yes, because that's right here, right? And this should be parent. Give me an X. We give an X. Yes, beautiful.
There we go.
Where did the dog go? Do not get messy on me, man. I think I
have to respect nature.
Yeah, I think I have to respect nature in this case. So, alright, so at least we're starting on our actual new board setup, so that's good. We figured out how to move forward, which is also very good. And I will respect...
The structure also fundamentally works now. I mean, you could of course do something much more optimal if you were just concerned about the cycle detection. I mean, you only basically need a map, one map. But for this, where we are rendering at the same time, I think we're getting close to something that works both for doing the calculation, and you can render from it, and you can read it also. I mean,
Indeed.
That's kind of the balance we're trying to hit here, right?
Yeah. and yeah, I'm going to do that. Yeah, that is very good, very good. So I think it was very successful,
Yeah,
and
small step, but it worked.
yeah, it worked beautifully. So let's continue this next week. And
Yeah,
will you be available next week?
I think so.
Yeah,
I'll let you know, but
yeah.
I expect so.
All right. Then I will. I don't know if I will be able to next week because it is holiday season here. So I need
Yeah.
to check with my wife what we are doing on Friday morning. Which
Yes.
you also don't want to mess with that, right? So
No, no, no.
no,
It's
no, no,
important.
no. So all right. So
But
let's.
let me know.
Yeah, I will. I will. And yeah, I will let the rest of the world know as well. So all right. Let's
Yes.
continue then. Thank you and see you next week. Goodbye.
Yes. Bye.